Hello everyone. In this video, we'll understand about graph isomorphism. Suppose we have two different graphs, whether those two different graphs, even though technically they may be different, are they same? That is the check. At that type of check, we call it as isomorphism. And if they are same, we call it as both the graphs are isomorphic. Let us consider two simple graphs, G1, which is denoted by V1, E1, and G2, which is denoted by V2, E2. These two are isomorphic if there exists a one-to-one and on-to function, means bijective function, f such that V1 to V2 with the property that A and B are adjacent in graph 1, A and B are vertices in V1, if and only if f of A and f of B, these f of A and f of B are vertices in set V2 in G2, are adjacent in G2 for all A and B in V1. G1 and G2 are called isomorphic graphs, and it is denoted by G1 equivalent to G2. Two simple graphs that are not isomorphic are called non-isomorphic. When two graphs G1 and G2 are isomorphic, it means that one can relabel the vertices of G2 to match the vertex names of G1 such that both graphs become equal. What are some of the conditions when we are given two graphs? How do we check? These are the conditions to be checked. For any two simple graphs, G1 and G2 to be isomorphic, following necessary conditions must be satisfied. Number one, number of vertices in both the graphs must be same. Number of edges in both the graphs must be same. Degree sequence of both the graphs must be the same. Same number of cycle of particular length in both the graphs. So all these are actually necessary conditions. That doesn't mean that once these conditions are satisfied, we can conclude that they are isomorphic. We can only conclude that it may be isomorphic. That means there are some sufficient conditions also which we need to check. All the above conditions are necessary for the graph G1 and G2 to be isomorphic, but not sufficient to prove that the graphs are isomorphic. However, if any of the above condition violates, then it can be said that the graphs are surely not isomorphic. Now, what are those sufficient conditions? We'll see that if any of the below conditions satisfy, then it can be said that the graphs are surely isomorphic. Two graphs are isomorphic if and only if their complement graphs are isomorphic. We need to check any one of these conditions only when we check for the sufficiency. Two graphs are isomorphic if their adjacency matrices are the same. Two graphs are isomorphic if their corresponding subgraphs obtained by deleting some vertices of one graph and their corresponding images in the other graph are isomorphic. We'll understand the above concept through an example. We'll see that below. This is the example. There are two graphs G1 and G2. This graph has got vertices V1, V2, V3, V4. Here it has got vertices 1, 2, 3, 4 and edges E1, E2, E3, E4, E5. Here also capital E1, E2, E3, E4 and E5. Now, first two conditions are verified already because we have already noticed that number of vertices in G1 is 4, number of vertices in G2 also 4. So condition 1 is satisfied. Number of edges in G1 is 5, we have seen that, and number of edges in G2 is also 5. So second condition also satisfied. Now let us check the degrees. Here already I wrote the degrees for each vertex. V1, since it has got 3 edges, 1, 2 and 3, and here also 1 has got 3 edges, 1, 2 and 3. So its degree is 3. Here also it is 3. Whereas for this V3 it is 2 because there are only 2 edges. For V2 it is 2 edges. For V4 it is 3 edges. So it is 3. So degrees are already mentioned. Now we may note that degree style is same. 3, 2, 2, 3. Here also 3, 2, 2, 3. So when we write it in sequence, we can write it as 2, 2, 3, 3. Here also 2, 2, 3, 3. So both the graphs have the same degree sequence. So condition 3 also satisfied. Now cycles formed in G1 are also getting formed in G2. What does it mean? Let us go back to the graph. We may notice here V1, V2, V4 and V1. There is a cycle getting formed which has got a degree 3, 2, 3. And here also we may notice 1, 3, 2, 1, which means it is 3, 2, 3. So same degrees. So here also 3, 2, 3. There is a cycle which is getting formed here this way and this way. Here also we may notice it is getting formed 3, 2, 3 and then 3, 2, 3. So it is in a similar fashion. So we can conclude that the condition 4 is also satisfied. Now we need to check for the sufficiency condition. For that, we can use any of the three conditions. So we'll use the first one. We'll draw the complement graphs and see whether. So for this, if I have to draw the complement graph, I should not have all these edges. I will have only an edge from V2 to V3. Here also all these edges will not be there. Only an edge will come 3 to 4. That will be the complement graph of both. We are going to call those complement graphs as G1 dash and G2 dash. So G1 dash will have this edge V2 to V3 connected, and then here G2 dash it will have connected 3 to 4, which we just now spoke about. So clearly we may notice if I tilt this V2 and V3 down and take this V4 up, it will become similar to this G2 dash. That means it is clear that G1 dash and G2 dash are isomorphic. That means the original graph, that is G1 and G2, are also isomorphic. That will be our conclusion. So we can say that the graphs G1 and G2 are definitely isomorphic. In case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.